Thank you for inviting me to give this keynote presentation. I'm humbled to be speaking to the world's brightest minds within subsea technology. I presume that several of you have been in the game since the start of the Norwegian subsea adventure, and what a journey it has been on the ocean floor. The first subsea development plan was for Elf-operated Nordøst Frigg. It was approved in 1980. Many Norwegian subsea facilities came on stream in the 80s. In addition to the Frigg satellites, Statoil had the Gullfaks A satellites and Tommeliten, and Norsk Hydro had the Oseberg satellites. Statoil and Hydro were pioneers. This was the start of a modern Norwegian industrial fairy tale which shaped us as a petroleum nation. And I think subsea technology will remain a key part of our future, both to develop new energy industries and to maintain the high value creation from the oil and gas industry. When we closed the books on 2020, we were pleased to see that substantial values were created on the Norwegian shelf, even in a year of crisis. Oil and gas worth more crisis. Kroner was sold last year, and the activity is high. There are 90 fields in operation. 11 wildcat wells have been drilled, resulting in 6 discoveries. 10 fields are under construction, and we are expecting many more. I'll return to that later. Drilling of development wells is the largest investment item on the shelf, and it is a good activity level. This figure shows that the number of development wells has been at a historically high level in recent years, and about half of the wells since the late 1990s have been subsea wells. This clearly shows that subsea technology has been and remains decisive for Norwegian petroleum. The high level of activity is reflected in the investments, which totaled around 150 billion kroner in 2020. This corresponds to an increase of just over 2% compared with 2019. We expect total investments to be around 140 billion kroner in 2021, slightly lower in 2022, after which they're expected to rise again. The overall level of investment for the next 5-year period is higher than the investment for the next centered a year and a half ago, before the corona pandemic set in. Largely caused by the impact of the temporary change in the petroleum tax, or the so-called tax package. The temporary changes in the tax regime provide strong financial incentives for the companies to submit development plans by the end of 2022. Our calculations show that the tax package frequently yields a reduction in the break-even price of $10 to $12 per barrel after tax. This helps keep investments at a stable, high level. We are facing a wave of developments and projects. We see up to 50 projects that aim for an investment decision by 2022. The resources amount to more than 1.5 Johan Sverdrup field. Project investments amount to between 350 and 400 billion kroner. The plans include development of discoveries, projects on fields, and power from shore projects. In our view, these projects both should and would have been carried out regardless of any tax package. But without the tax package, we expect that several would have been postponed. So it's important to remember that this is a snapshot of a moving. It's important to remember may be postponed, but in general we see a strong will in the industry to submit the development plans by 2022. We are interested in progress in all projects that are profitable. Another positive effect of the tax package is another positive in time-critical projects. But there are some challenges. First of all, must be sufficiently matured before investment decisions. No hasty decisions must be made to reach the deadline in the tax package. Secondly, the companies must always choose solutions that provide the highest socioeconomic value. We have to avoid overheating the market and a new substantial growth in costs. And last but not least, the companies must have a long-term perspective longer than 2022. Over the last 2 years, 80% of the exploration wells have been drilled less than 30 kilometers from existing infrastructure. Slagugle in the Norwegian Sea was proven towards the end of last year. And so far this year, interesting discoveries have been made both near the Fram field in the North Sea and Johan Castberg in the Barents Sea, just to mention a few. Most discoveries on the shelf are relatively small though. In spite of this, they can generate considerable value with cost-effective development solutions. According to our calculations, the average unit cost for discoveries over the last 10 years is $21 per barrel. If we compare this with the national budget's projected future oil price of $50 per barrel, it's obvious that this provides a significant potential for value creation. Most discoveries that haven't been developed yet are located within 40 kilometers from a potential host installation. Based on this, we expect the vast majority to be developed as subsea developments phased in to existing host fields. In many cases, phase-ins are also beneficial for the host field. This figure shows unit costs for typical host fields with and without tie-ins. Tie-ins contribute to reduced unit costs for the host field. They frequently extend the economic lifetime such that a larger share of resources will be profitable to produce. So, this is a win-win situation both for satellites, hosts, and the society. For 40 years, subsea technology has been crucial for resource utilization on the shelf. This could not have been achieved without extensive technology development. One recent example is subsea compression. On Åsgard, this has increased recovery by the equivalent of 1.5 Edvard Grieg field. And on Ormen Lange, the licenses are working on a possible subsea compression that will increase recovery by about 11%. We expect to receive a development plan during the autumn of 2021 on this. Subsea water injection is another example, which is now in the early stages. The solution could make it easier to utilize water injection on the fields by reducing both costs and emissions. And then we have the all-electric subsea, which could provide considerable cost savings, increased efficiency, and tie-ins over longer distances. And the development extends beyond hardware. New digital technology has, for example, made us able to process and utilize vast amounts of data. This has many potential applications, such as in combination with 4D seismic to increase subsurface understanding. In turn, this gives better reservoir management and resource utilization from the fields. This is very exciting, and the technology development must continue. Considerable amounts are invested annually in research and development, and a significant share of these investments are tax deductible. We expect that the considerable amounts invested will lead to improvements and the application of new technology to increase value creation. That will be what will be the next big step. A potential new activity on the Norwegian shelf is mining of seabed minerals. The minerals are rare and highly requested, and they are, among other things useful needed in the transition to a lower emission society. For example, electric cars, wind turbines, and solar panels. The government has initiated an opening process for mineral activities. The plan is to implement a licensing system equivalent to the one we use for petroleum activities. Mapping and future production of minerals is a textbook example of how production of minerals developed for petroleum industry can be useful in new industries. And the NPD, we have had front row seats. We have been cooperating with the universities in Bergen and Tromsø for several years on collecting data and mineral samples from the seabed. Last year we conducted an independent seabed. Last year we took core samples at the water depths of up to 3,000 meters. This expedition was carried out by Norwegian suppliers with extensive experience from the petroleum industry, and coil tubing technology were used. We're planning a new expedition this year, and the fiscal budget for 2021 appropriates 30 million kroner for mapping seabed minerals. New industries on the shelf. Many of them benefit from technology developed by the petroleum industry. A few examples. The offshore wind project Hywind Tampen is well on the way, and the government has opened up 2 new areas for offshore wind development, Utsira North and Southern North Sea 2. The Longship project and Northern Lights involve storing CO2 in the subsurface. In addition to a large and significant fishery industry, work is also on the way to plans for offshore fish farms. And some are fish farms. The production of hydrogen from natural gas could be yet another new offshore industry in the future. A number of players are emerging with a desire to participate in the development. This is good. Good coordination of access to acreage is essential to ensure the greatest possible value creation from all industries based on the shelf. A system that builds on the licensing system for petroleum can provide for the new industries. Sound management and distribution of shelf acreage is important in order to realize the value potential in the various maritime industries. Then I'd like to say a few words about the excess industries. The low number of applicants for the petroleum-oriented studies has created attention and debate. There are many good reasons why young people don't want to educate themselves for a career in the petroleum industry. For example, uncertainty about the future. How long will last when some politicians want to finish up the industry altogether in the near future? Or because they don't want to work in an industry because they don't want greenhouse gases and to climate change. It is important to communicate that petroleum industry will continue to offer interesting jobs for many years to come. Oil and gas will be needed for decades to come, despite a future decline in their contribution to the energy mix. And the revenue can help us transition into a low-emission society. Oil companies and the suppliers are expanding their portfolios to utilize other energy resources, while at the same time continuing to produce oil and gas. Expertise has always been important for the development of the Norwegian shelf, and there are no signs of it becoming less important in the future. Bright minds are needed both to find and produce oil and gas in the best possible way, and also to develop the new industries. In the future, I don't think we have to choose between working in oil and gas or renewable energy. The industries will melt into a collective Norwegian energy sector. Finally, here's our production forecast leading up to 2030. It shows that we are expecting continued high production throughout this period. And yet again, we can see the importance of the contribution from seabed wells. Subsea technology will be completely decisive in realizing this forecast in order to ensure continued high revenues for the Norwegian society and to succeed in the energy transition. The industrial adventure continues. Thank you for your time.